All right, so we're riding here in Chico along Warner Street, just past the CSU campus. Got a little wiggly camera here. There we go. Up and over the bridge. I think we'll fit. So this is pretty fun, pretty easy. Just kind of cruising along here. I'm going to make a right turn here. I'll catch up with you in a second.
This is Peak Moment. We are living at a peak of human innovation, information, wealth, and health. But we're also at a peak of population and consumption, with rising temperatures and declining resources fueled by cheap oil and gas. Peak Moment Television, bringing you examples of positive responses to energy decline and climate change through local community action.
Hi, I'm Janaia Donaldson, and welcome to Peak Moment, community responses to a changing energy future. As the prices of oil increase and we have less of it, more and more folks are going to turn to alternate forms of transportation. And the least expensive, oil-wise, is human-powered transportation. I'm here at the McConnell Technology Center in the Engineering College at Chico State with my guest, Galen Shumacher. Galen, welcome to Peak Moment.
Thanks for having me, Janaia.
Galen is a senior in the mechanical engineering department, right, and he is sitting on last year's project. What is this, Galen?
This is the Chico State Human Powered Vehicle Club vehicle. It's an extracurricular club that the school has here. And there's an intercollegiate competition that's hosted at different places each year.
And was this created for that competition for last year, is that right?
Exactly, yeah. This is last year's vehicle. There's about 10 of us who are involved in it, and we put this together kind of in our spare time and go race every year. It's in the end of April.
So describe what you've created here.
Okay, well there are a couple of main configurations of human-powered vehicle. There's a 2-wheel and a 3-wheel. This is the 3-wheel version. It's known as a tadpole configuration, 2 in the front and the drive wheel in the rear. It's made out of aluminum. We have an adjustable seat here. There's a roll bar up above and beyond me. We have steering right here, right and a left brake, and it's powered right here by the crankset. The race has several different riders. It's a relay format, so the vehicle has to be adjustable to accommodate several riders. We have 1 woman and 3 men in the relay endurance event.
So each person adjusts it for different, height or leg length, or is that what you mean?
Exactly, all the above. During the race, we'll switch out. There's an aerodynamic fairing that fits over the vehicle, which isn't on right now. That opens up, and then we switch out riders. So it's a whole lot like the scenes of the pit that you see in car races.
So how is this kind of vehicle or the competition, in what way might that be sort of the wave of the future? Is this the kind of thing that we're only going to see, in extreme sports, if you will, or custom things? Or is this the kind of vehicle that we're going to end up seeing more of on the streets in downtown as people are getting out of their cars? Where is this headed?
Well, the Chico State Human Powered Vehicle Club is really has been pursuing the performance aspect, but there is a utility event within the race, and this could pretty easily be converted to the utility event. In that event, they have a rack on the back, and they navigate some different obstacles, some tighter obstacles like you might see in an urban environment, and then we'll get out and place a load on the vehicle, back it out, and then continue maneuvering around the course. So this would be very easily adapted by putting, say, a rack behind me over the rear wheel to an urban situation, to a more utilitarian type of application.
You make me think about here in Chico, I see that you've got rickshaws or pedicabs. You've got bicycles with ridden by one person in the back seating for a couple of people. They're just little bicycle taxi cabs going around town. Has anybody adapted this idea for a little taxi cab?
No, not that I've seen. That would be pretty good. The one, I think, downside to this type of vehicle is that it's quite low to the ground. So we'd have to have some kind of attention-getting device, say like a system of flags up above and beyond it, so that it was a little more visible to auto traffic.
Are these tadpoles, is anybody making them commercially? I mean, is that a direction that your designs could go, is into commercial production some way?
Yeah, that could happen. There is a company called Greenspeed that is making a similar configuration vehicle. So for folks who are interested and maybe didn't want to go through engineering and fabricating one themselves, they can go ahead and pick one up, and they can find info. They have their own site, Greenspeed, something like greenspeed.com, I believe. Yeah.
Now, why would someone think about a three-wheeled vehicle or such a low vehicle as compared with the standard bicycle configuration? What's the difference in riding or maneuvering or weight or whatever?
Well, there are two main benefits to this configuration. One of them is aerodynamics, especially with a fairing placed on it. It greatly reduces the resistance that you feel as you're riding it. Another one is maneuverability. It's really easy to maneuver, and you'll see this. Maybe we can get you on it later. Okay. And it's quite easy to zigzag around. It's really intuitive. So someone who hasn't been on it before can easily jump on and start steering it a lot like their car. And these front wheels are placed so widely apart that you don't have to plan ahead as you do on a two-wheeled vehicle. You can just go ahead and turn it.
Well, I also see, of course, three wheels. It's going to be more stable, so you don't have to worry if you're about tipping over or keeping your balance when one is riding. I'm also trying to think about appropriate human-powered vehicles for slow-moving traffic or slower people. Folks that are older or perhaps handicapped, this is probably going to be a more secure feeling if we can deal with your lower to the ground situation. Do you think that's fair here?
Yeah, that's entirely accurate. You have to try really, really hard to lift one of these tires off of the ground. You have to go very fast, turn very tight. So that's a really hard situation to find yourself in. You have to pretty much try to get yourself in trouble.
And what about weight? How does the weight of this compare? I'm trying to think if you're going to have to do some hills and so on. I mean, you're in the flat in Chico, so you have it easy. Mm-hmm. But if we're going to do hills or gentle rises, are you having to deal with more weight? Is it harder? I mean, there's an ergonomic situation here where your body's in a very different position than you would be in a standard two-wheel bicycle. Are there advantages to this position compared to your two-wheel bike?
Well, as far as your first concern about efficiency on the hill, I would say, yeah, it's a little less efficient on the hill. I would say that you're in a more comfortable position because, well, you can see I'm sitting here in a pretty comfortable reclined position. I could sit here all day long and it wouldn't bother me. So although it may take you longer to climb a hill, the average person, I think, would be more comfortable climbing that hill, even if it did take them longer. Yeah.
Tell us a bit about the competition. What that I'm guessing other colleges are doing, are entering into it. I mean, where do the winners go? Is it just for the fun of it? Do you have manufacturers looking for new ideas? I mean, what ideas did you learn from running this in the competition? How did you do last year? What did you learn from that too?
Well, let's see. I'll start off with how we did. We did really well. We got third in the sprint. We did first in the endurance event, which I'm really proud of. I was one of the riders in that, by the way, so that was really exciting for me. And most schools will approach this as an kind of an opportunity to practice their engineering skills and fabricate something to themselves. So it's, for the most part, kind of for the engineering experience that schools are involved in this. Oh, and there are 21 schools that competed at Fresno State last year.
I'm thinking about the roll bar here. I assume that there are some minimum set of requirements you've got to have for a vehicle. I mean, is that a requirement, a roll bar?
Yeah, absolutely it is. The ASME, the Association for, well, I've forgotten the acronym.
Structural mechanics or something?
Yeah, it's a mechanical engineering standards firm, and they actually sponsor the event. And so, yeah, there are a lot of standards, and the roll bar is one of them. A seat belt is another one. That's pretty fundamental.
Okay. So, I don't know how much time we have left here to talk about this. Oh, good. We have more time. What do you feel like this is any part of the direction that you want to go in the future with your career? I mean, do you want to keep pushing where the edge of human-powered vehicles? Is anybody doing, what'll I say, the trailers that ride behind this? I mean, it seems to me that where we're headed in our culture, this is going to be a lively new industry.
It would be nice to see that. I don't think we're at the point right now where a lot of American companies are pursuing vehicles like this for transportation. I think we see most of it as the sport application right now, but there's going to be a point where it becomes a much more viable transportation method, and we see people really moving more towards that. Yeah, absolutely.
So Galen, tell me, how would you carry luggage on this? How would you carry your groceries on this model?
Well, right behind me, on the rear wheel, I can let me show you.
Now we get to see how you get out of this contraption, huh? Okay.
So right back here, a rack could be fitted, which can hold different things.
Here?
Yeah, right in this area would be the best spot to carry cargo.
So you guys haven't tested, because this isn't your utility bike. This is your sports bike, if you will. Did you allow for that just for the fun of it, for the design, or say no, that's not the category we're in? We'll just not worry about it.
Exactly. We chose the sports category so that we could. Well, that was kind of the route we were interested in going. But we did actually consider using this last year's vehicle and adapting it to go for that utility category competition too.
I would expect that you've got this design so that the weight balance among your wheels works well with your center of gravity, where your bottom is here. And if you add weight with, a couple big bags of groceries or books and so on, does that how much tolerance is there in the design here for that kind of weight change?
Well, it wouldn't affect this one too much, but I would say that in a commercial application, it would be a little bit better to extend the wheelbase here a little bit to compensate and make that work out a little bit better.
When you ride this, is this safe, this bike, can it be ridden both in the bike lanes? Is it also legal to ride in the car lanes when you're driving in town? And if so, how do you make sure that the vehicle, motor vehicle drivers see a vehicle so low to the ground? How do you do that?
Well, as far as the visibility, I would recommend a system of flags maybe extending up from the roll bar here, or maybe in a commercial application there wouldn't be a roll bar. So that would be a way to go. And the first part of your question was
Can you
what
drive
again?
in the car lanes?
Okay, my knowledge of that is that you're fine as long as you yield to faster traffic. But that's something that we'd want to check out a little further before we did any super long rides on this on the road. But we have ridden it around here, and the police seem to be fine with it.
It's good to know. I'm going to pause for a second.
Okay, we're live.
So in the endurance competition that this bike was in, I understand there were three-wheelers like yours and two-wheelers. Is that right?
Yeah, that's right. We had both configurations of the vehicle in that race.
And so if we look at maybe is this more efficient or ergonomically for the body, your three-wheeler beat out the twos.
Yeah, it's true. I think it was a combination of probably the ability to more consistently apply power to the pedals and also the stability that the three-wheel design offers.
Well, let's take a look at how this thing really rides. Would you give us a little demo of working on it?
Sure.
Go for it.
Okay.
God, that looks so easy and fun. I wouldn't try that on a two-wheeler myself. I'll meet you out at the workshop.
Okay.
Let's take a look at this year's model. Now that's maneuverability. We're in the lab where Galen and the other students are creating the model for this year's competition for the intercollegiate human-powered vehicles. And this looks a whole lot different from what we've just been seeing. What have we got here, hey, Galen?
Well, let's see. It's a similar kind of a configuration. It's a tadpole, 3 wheels total, 2 in the front, 1 in the rear, but we're using a totally different approach as far as the materials that we're using with this. This is carbon fiber. It probably comes across as blackish gray on the film, and I have a couple of samples right here of what we're using. This is the raw carbon fiber, and this is uncured. You'll feel it's quite flexible right now.
It's like it's kind of plasticky. But it looks woven in here too.
Mm-hmm. It's a composite, so it's a combination of a cloth and a resin, and they work together to give it its structure.
So is this sort of like fiberglass plus or something like, I mean, old world fiberglass?
It's very much like fiberglass. That's a composite too, except for instead of glass fibers, we're using a lighter, stiffer carbon fiber, and that's where it gets its name. And then we've laid it up in this configuration where you can see a structural foam core, and that's a sandwich configuration, so those stiffer layers of carbon fiber are spread apart from each other, and that's the kind of the magic in the structure.
Does it make it stronger? Obviously, it's very lightweight. It's a very lightweight foam. What's the magic?
It's using the high tensile strength of the carbon fiber and spread out. This foam actually spreads it apart. It's kind of a placeholder so that the high stress areas in the structure can be strong, and the parts that aren't undergoing much stress are essentially void. That's what the foam is.
So why did you move to this from the aluminum frame that you had before? What is this giving you that you want?
Well, it gives us the potential to be lighter, and it definitely makes the structure stiffer. For example, this is a test apparatus that we have built and tested, and we loaded this with 850 pounds. This member right here weighs 1 kilogram, so 2.2 pounds, and held over 850 pounds before it broke. So quite strong stuff.
So what we have the potential here for a lighter vehicle, which means less work to power it, right? And more strength for whatever, not that you're going to want to get collisions, but more strength for carrying more load as well. Mm-hmm. Yeah?
Mm-hmm. Yeah, exactly. Those combine to what we would call performance. Mm-hmm.
So let's see. Let's see. Where am I? This is upside, hello. Give us an orientation to what we're seeing here.
Okay, well, when we were riding this, we'll be pointing that direction. So this deck right here is a seat that we would sit on. The cranks and pedals will be right here, okay. And then front wheels here and here, exactly, okay. And the rear wheel in the back. You'll recognize the roll bar right there. Mm-hmm. Okay. And that looks a little bit different because it is a hybrid of Kevlar and carbon fiber, so it has a little bit more of a yellowish look to it. And that has it's much safer. It has a safer mode of failure. Mm-hmm. Mm-hmm. We made one like this and tested it. Brought it up to 600 pounds of pressure before it broke. It's actually 600 pounds of force, excuse me. And then it held another 300 pounds, and it cracked again, and another 300 pounds. And we have that here, and we can actually you and I could still stand on it, and it would still support us.
Wow, it's wonderful to see what new materials are being used. I mean, to keep the edge going. What's this? What do we got here? Oh my goodness, that's just feather light. Move our table out. Let's come around back.
So this is the plug for our aerodynamic fairing. A plug is like a mold. So you can think of it as the opposite of making an angel food cake or something like that, where we actually use the shape, the cake, to make the mold over it, and then we'll remove that fairing as a peel, like an orange peel.
So you'll put you'll create a shape over this. Where's the front end and where's the back end?
This will be the front end, so it's pointing the same direction that the frame was earlier. And yeah, we'll essentially smooth this over, do a layup, which is forming the carbon fiber composite like we held in our hands a second ago, and then we'll peel that off and maybe do a little more reinforcement, and then that'll fit right over the completed vehicle.
And didn't you say that part of that fairing at least gets moved aside so you can get in? Is that right?
Mm-hmm. Yeah, it opens up. There'll be a hatch that opens up a whole lot like a jet airplane or the hood of a car, and that's how the rider will switch in and out. So it won't be a single piece. It won't be like the shell of an M&M. It'll be 3 pieces that open up. Mm-hmm.
And with the fairing, you said it's more aerodynamically efficient. I would expect that down the road, as we get commercial vehicles made out of this, that's going to keep the rain off or the mud off. Is it designed for that too?
No, that's kind of a great side effect, though. It's a great, real practical application of having the fairing. Is that, the rider's protected from rain. The luggage, the cargo could be protected as well. So, yeah, that's a great application.
So how many people are working on this? How many people will be in your competition? How many in the team?
Well, in the team overall, there's about 10 students who are involved. As far as building that frame that we just looked at, the carbon fiber frame, there are 4 students who are mostly involved in that. We've taken this on as a senior project because the degree of difficulty is so much more difficult with a composite material versus the straight aluminum as we saw on last year's frame.
Now that's enlightened. I think to have your student projects be real world and real practical and things that you enjoy, can't get much better than that, can it?
It's been real enjoyable. It's been a great experience, which is a good thing because we've had to put a lot of hours into it, a lot of late nights. And the competition happens before our usual senior project presentation, so our deadline is advanced by about 2 months over most other students. So it makes for long nights and long days. Mm-hmm.
Well, it looks to me like you get a lot of reward from inside yourselves because you're doing something that you love. You're having a good time with. So that's great. Yeah. This is Peak Moment, and I want to now turn to the opportunity to give it a spin myself, since I've never ridden something like this. I think that'd be fun. Can I give it a try?
Yeah.
Okay. Well, this is the moment I have been waiting for since we started. I get my chance to ride the what are you calling it?
The human-powered vehicle.
The human-powered vehicle here, the HPV. Okay, Galen, where do I start? How do I get into this contraption?
Well, first you're going to straddle the seat.
Okay,
so
okay.
Well,
You got that?
Great.
Yeah.
Okay, now go ahead and slide down and then kick your feet on over where the pedals are.
Okay,
Great,
feet.
Perfect. You're good
Feet.
at that.
Hey.
So you have your shifter right here. You have a left
Shifter.
brake.
Yeah,
and
left
a right
brake.
brake.
Left brake.
And
What do I have to know about the shifter?
Well, you don't have to know much about it right now.
Okay, okay.
But if you wanted to, that will go into higher gears and that will go into
To lower gears.
Yeah.
Let's
And
go back to low. No, wait a minute, you got me
low.
back to there.
Yep.
And so I have, we got what, disc brakes? Are these on the front? We
they're
got
disc
left and
brakes.
right brake. Okay, all right.
This has 2 front brakes, a left and a right, and that offers us advantages in that we can actually pull the vehicle into a turn.
With a brake.
Yeah, so you can
Cool.
slow and navigate at the same time.
I'm not sure I'm going to figure that out on the first round, but we'll see. Okay. Just lift off and pedal. Is that where we are?
All
Okay.
pretty straightforward. There you go.
Hey.
Right.
Woo! Woo! Oh, the brakes work. Woo! Woo! Ah! Oh, this is cool. Oh man, sharp turns even. Oh. This is fun. Oh. Galen. Woo! And the brakes work. I can tell the brakes work.
That's right.
Which matters. Oh, this is fun.
So that was your first time on it. Did it feel pretty natural?
Yeah, yeah. You get, there's a little feel. It takes a little bit to feel where you're. How do I say this? Well, it feels natural because it's like when you drive. You know, you're turning your steering wheel like that, and it's much. Once you get going, I mean, it's like this thing flies, which I can't get a bike to do like this does. Oh, bye! I'm just gonna. Woo! What it really does, that I see, is the sharp turns that are so stable. I mean, you can just turn on a dime. What fun. What fun. I think this is the wave of the future. I want one. How much would one of these things cost if you were, you know, the ones that are commercially made? How much would one of these cost now?
Well, I don't remember any prices right off the top of my head, but I think in the $800,000 range, you could probably buy something a lot like this.
You know?
$800,000 range.
800
No.
to $1,000. That's you know, there's a lot of gas money that could get saved to be put into this. Great. It's not every moment you can have a peak moment having an adventure on a human-powered vehicle. This is Janaia Donaldson. Join us next week for Peak Moment, Community Responses to a Changing Energy Future.
Okay. Feel good? Yeah. All right. Feel free to go as fast as you want. Nice and maneuverable. Just move right around the other cyclist. It's kind of fun being this low, just pedaling along, cutting through the wind.